Hello, this is the first A2 trig video for distance learning. It's on evaluating trigonometric ratios. The exercise paired with these notes are on page 726, 727, but that exercise has not been assigned yet. It'll be assigned probably this week, which is April 22nd, which is when we're supposed to meet, but in case we don't meet, it's still an assignment assigned on April 22nd, due the following week. So this is not brand new stuff because I know we went over some of this just before school was closed. So some of it you may remember from then, some of it you may have had in the past, and some of it might be new. So first I'm going to just write down a couple of foundational things for you to depend on if you ever get stuck thinking about these trigonometric ratios. The first foundational thing you have to know is your special triangle ratios. So the special triangles we want to keep in mind are the 45, 45, 90 triangles and the 30, 60, 90 triangles. The ratios go like this. This is how I like to remember them. Of course, these are ratios, so you can use a multiplier and change these numbers to things that you're more familiar with. Oh, sorry, that one was wrong. Okay, so the hypotenuse there is 2. Short side of the 30, 60, 90 is 1. And the long leg is rad 3. And for 45, 40, 90, it's 1, 1, rad 2. Some people prefer to remember in the 30, 60, 90, they prefer having the hypotenuse be their 1, which would make the short side 1/2 and make this side rad 3/2. But in the end, it doesn't really matter. And of course, you should know the basic ratios. Sine, which is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. And then the reciprocals of these, which are cosecant, I'll just write 1 over sine, secant 1 over cosine, cotangent 1 over tangent. And the third thing you need to remember as foundational is when are these trig ratios positive and when are these trig ratios negative. So for that I go back to the unit circle. And I'll draw just a few generic right triangles. So for example, in quadrant 1, if you are looking for the sine of this angle, then it's going to be positive because the opposite side has a positive value, and the hypotenuse side always has a positive value. That is as opposed to, let's say, in quadrant 4, if you're looking for the sine of this angle, this opposite side, even though it is a length of a geometric figure, is considered negative because direction in a unit circle matters. Direction matters. And this is considered down because this is still you can think of it as a point with coordinates x comma y. or in this case cosine theta, sine theta. And so direction matters, which makes this length negative, so to speak, and the hypotenuse is still positive. The hypotenuse in all four of these triangles is going to be positive. So the only thing that really matters, the only thing that will affect the sign of the trig value of a particular angle is going to be the opposite side. The opposite side. It might be the adjacent side also, because if you're looking for the cosine of an angle, let's say back to quadrant 1, this angle you want the cosine, it's adjacent over hypotenuse. So the cosine is going to be positive because this adjacent side in quadrant 1 is positive because you're going to the right in quadrant 1 to find it, and then up to find the location of this point. But over in quadrant 2, you're going to the left and then up to this point. So when you're going to the left, that's a negative direction for the x-coordinate. So adjacent over hypotenuse in this case would be negative. So this angle will have a negative cosine value. In quadrant 3, this angle would also have a negative cosine value because you're still going to the left for adjacent. In quadrant 4, the cosine value would be positive because you're going to the right. Now there are two trig ratios that don't involve the hypotenuse at all. That would be the tangent and the cotangent. So I'll go back to quadrant 1. Opposite over adjacent is tangent, so opposite, which is positive, over adjacent, also positive, would give you a positive ratio. But in quadrant 2, opposite is positive, adjacent is negative, so the tangent of that angle is going to be negative. Moving on to quadrant 3, opposite negative, adjacent also negative, so negative over negative gives us a positive tangent value. And then in quadrant 4, opposite is negative, adjacent positive, so negative tangent value. And the cotangent would follow this in the same manner because cotangent is still using the opposite and adjacent sides, just the reciprocals of what the tangent would give you. So the signs will be the same. So in summary, just going down the trig ratios one by one. Sine will be positive here, but negative down here. Cosine will be positive anywhere in here, quadrants 1 and 4, but negative in 2 and 3. Tangent will be positive quadrant 1, quadrant 3, but negative in quadrants 2 and 4. And then for these three, cosecant will behave the same way as sine. Secant will behave the same way as cosine. And cotangent will behave the same way as tangent. Now there are a couple of strange situations that give you neither positive nor negative values. So that means it'll give you a value of 0, or it could give you a value of undefined. So let's go back to the unit circle. Let's pretend we have a triangle in quadrant 2 that's it's very close to the y-axis, so it's like this. So it's this hypotenuse is nearly vertical, but not quite. And I'll draw one in quadrant 1 also. So it's a mirror image. So both of them have a hypotenuse that is almost the same length as the opposite side. So if you're trying to find the cosine of these two angles, you would take the adjacent side and put it over the hypotenuse. Adjacent side over hypotenuse. But that adjacent side is really, really small. And the hypotenuse is approaching 1 as you get closer and closer to 90 degrees. So eventually the trig ratio is going to be 0. When you hit that 90 degrees, it's going to be 0 over 1. So in that case, the cosine is 0. Now let's take a triangle that's skinny in this direction. So now we want, for sine, the opposite side over the hypotenuse. But that opposite side, as we get closer and closer to the x-axis, it is becoming small. It is approaching 0. And the hypotenuse is always 1. So we've got, when it gets to, when this hypotenuse hits 0 degrees, when it's horizontal, we have a cosine value, a sine value of 0. And over here, the same thing would happen. When this hits 0 degrees, we'd have a sine value of 0. The cosine value for this triangle, when that hypotenuse hits the x-axis, would be 1, because when it hits the x-axis, the hypotenuse and the adjacent side have the same length. They're both 1. Over on this side, the cosine would be -1. And then we have the situation where you have an undefined value. I'll use a triangle like this, skinny one down in quadrant 3. So if this angle approaches the y-axis down here, the opposite side is approaching the same length as the hypotenuse, and the adjacent side is about to disappear. So if I have a trig ratio that uses the adjacent side in the denominator, that means we're going to eventually have something over 0, and that would give us an undefined value. So something over adjacent would be tangent. So when you have when this triangle hits the y-axis below the x-axis, that angle is 270 degrees. So that is going to be 1 over 0. So that's undefined in that case. You would also get undefined for that same triangle, the one that's directly straight down. You would get that for cosine, I believe. Yeah. Cosine of 270, that would also give you, yeah, undefined, because cosine is adjacent, or secant, sorry. Secant of 270 would give you undefined, because secant of 270 would be 1 over cosine, which is hypotenuse over adjacent. And when you're straight down, the adjacent side has disappeared. Okay, last thing before I give you a few examples that you need to remember is reference angles. All of these triangles I drew here have a reference angle. And by that I mean the angle, I'll draw it again, this angle, that's a reference angle. This angle, that's a reference angle. This angle, reference angle. This angle, reference angle. So all of those 4 angles have something in common. They each use as their rays the x-axis and then the hypotenuse of whatever that triangle is. So it's always the x-axis with the ray that is the hypotenuse of that triangle. And you use this reference angle to figure out the ratios, because that reference angle if it's a nice, clean, convenient angle, is going to be a 60, a 30, or a 45. So for example, if I wanted to find the sine of some angle like 300, I draw my axes, and then I know 300 is somewhere over here. I draw my triangle. So that's 300. But the angle that I need to help me is this angle, 60. And that 60 is going to be made with the x-axis and this ray. Not this angle over here, between the y-axis and the ray. It's always the x-axis and the ray. So then you get your 60, and then you can label your triangle with your ratios. Since you know this is 30, you know it's a 1, rad 3, 2 triangle situation. And then since we're looking for sine, that would be opposite over hypotenuse, rad 3 over 2, but you got to make sure you got the right sign. So it's negative rad 3 over 2. Okay, so that's reference angles. Okay, we're going to do a couple of examples, 4 to be exact. Okay, so we've got 20 sine of 60 cosine of 240. First thing I'm going to do is draw my axes, and you don't have to draw the unit circle, but this time I'll do it. For the next example, I'll probably just draw the triangles and drop the circle. So I need to find out sine of 60 and cosine of 240. Sine of 60 is in quadrant 1. It's more than 45 degrees, so I'm going to draw it like this. And 60 is my reference angle, so 1 rad 3, 2. I need the sine, so that's rad 3 over 2. So far, I have that. Now I need cosine of 240. 240 is in quadrant 3. And it'll be like that. So 240 is this angle, but I really only need my reference angle, which is this angle. And that's also 60. The 1, rad 3, 2 is my ratio again. I need the cosine this time, not the sine. So I'm going to take the adjacent and put it over the hypotenuse. That's 1/2. Last thing I do, check the sine. It will be a negative 1/2 because I'm using the adjacent side, and the adjacent side in quadrant 3 is negative. Okay, so I got all my values. I just need to simplify. Negative 5 rad 3. Okay, example 2. Okay. I'm just going to draw the triangles in this case. I'm using 60 degrees 3 times, so I really need that one. That's in quadrant 1, 1 rad 3, 2. So I'm going to use this triangle to get secant, cotangent, and sine. Secant is 1 over cosine, so that's hypotenuse over adjacent, so that's 2. And I'll get the tangent 135 in a minute. Cotangent 60, so that's adjacent over opposite, so 1 over rad 3. Sine, we just did that one, rad 3 over 2. And all three of these are going to be positive because we're in quadrant 1. Tangent 135, that is in quadrant 2. So I'm going to draw my triangle like this. Quadrant 2. And so this is 135, if you can imagine the axes here. So that makes my reference angle 45. So this one is a 45, 45, 90 triangle. 1, 1, rad 2, 2. And they want the tangent 1 over 1. That's just 1. So simplify that. 2 minus a half, 1 and a half, or 3 halves. Third example. We're in radians now. Okay, when you're confronted with radians, you either memorize your radians or you convert them into degrees if you don't have them memorized. I'll convert it. So to convert 4 pi over 3 to degrees, you just multiply by 180 over pi. And so that's 240. And this one's the same angle. So we're going to use one triangle for both of these. And we are in quadrant 3. With a reference angle of 60 here. So I need the sine, the 4 is just that 4. I need the sine of that. Negative rad 3 over 2, because I'm in quadrant 3. Negative 1/2, because I'm in quadrant 3. Both cosine and sine are negative in quadrant 3. And that becomes rad 3. Okay, final example. Okay, if you've had some trig, you already know what the answer is. But I'm going to work this out the long way, then I'll go back and talk about the identity that is illustrated here. So 2 pi over 3, convert to degrees, is 120. So we are in quadrant 2, like this. 120. So this is 60, 30. 1, rad 3, 2 are my sides. I want, so about a little bit about notation. So this means the same thing as that. Same thing. Writing it this way just saves us the time of drawing the parentheses. Okay, so I need the cosine. That's going to be negative 1/2 squared. I need the sine, rad 3 over 2, not negative, squared. 1/4 plus 3/4, and we have 1, sorry, which is what we would have expected, because this example is an illustration of what's called an identity. We won't talk about identities until chapter 14, but this is such a convenient one, I'll go ahead and explain it now. So there's an identity that states if you have the cosine of any angle theta squared, and you add it to the sine of that same angle squared, the result will always be 1. Always. And that's what we have here. In our example here, theta is 2 pi over 3. So a seasoned trigonometric student would automatically say that's 1. Okay, so those are the 4 examples. They come from your book. I picked even numbered problems from your book in the exercise on page 726 to 727. So if you feel comfortable, you can go ahead and do some problems from there. I'm going to formally assign problems from those pages on the 22nd, April 22nd, which is in a couple days. But you can go ahead and do some of them now if you want. Okay, this concludes the first video.